Hello and welcome to this session, and in this session we shall continue our understanding of the important software terminologies. Well, that way in this session we will have to understand as to what glitches are and what we mean by a system crash. That way, glitches and system crashes are not the same. Then what really is the difference between them is also something that we shall be understanding in this session. So let me proceed and explain to you as to firstly what glitches are. Have you ever noticed your screen flickering or your sound going haywire for just a second? Well, that's what we call a glitch. That way, a glitch is a temporary fault in your computer program that causes unexpected or irregular behavior. No doubt, glitches are short-lived and usually go away on its own, but then they can be caused due to many reasons. It could be the software bugs in your program, or it could also be due to certain hardware issues. But then there are different types of glitches. Firstly, the graphics glitch. Well, this happens when you see distorted images or flickering images on your screen. The next common type of glitch is the audio glitch. This includes problems like skipping sound or sudden volume increase or sudden volume decrease that can actually mess with your audio experience. And then we have something called as the input glitch. Well, this occurs when your keyboard or mouse or controller suddenly becomes unresponsive or behaves unexpectedly. And then there is also something called as the behavioral glitch, and this happens when your program suddenly freezes or crashes or starts acting in an erratic way. So that way, all of these happen to be the different types of glitches that we normally encounter. But then let me also tell you that glitches normally are temporary, and luckily they go away with just a quick refresh. Now that you have understood as to what glitches are, let's understand as to what a system crash is. Well, a system crash happens when your computer program or when the operating system or the entire software system itself fails completely. It's a kind of a sudden shutdown that is caused due to a critical error. Well, due to this sudden shutdown, you would not be able to continue using your computer. That way, in the system crash itself, there are two types. We have something called as the soft crash. We have something called as the hard crash. Well, in case of the soft crash, no doubt we are hit by a critical error in the program, but then we call it as a soft crash because the shutdown happens to be in an orderly manner. We may also be warned and get a message indicating that the system will shut down in a few seconds. Well, that way we can also recover our important data from our computer if in case the computer has encountered a soft crash. But then the hard crash, as the name itself suggests, is pretty hard. What I mean to say is that even in the hard crash, no doubt our computer system stops working altogether, but then we call it as the hard crash because we may not get any warning messages before the system actually comes to a grinding halt. Also, another aspect associated with the hard crash is that we may not even be able to recover the data that is there on our computer system. So all said and done, whether it's a hard crash or a soft crash, both type means that the system has encountered a serious problem and could not be continuing its operations as usual. Well, that way, I had previously told you that glitches are temporary and that we can overcome the glitches by just hitting the refresh button. But then, in case of the system crash, just hitting the refresh button would definitely not suffice. Rather, you may have to manually restart the computer all over again. Now that you have theoretically understood as to what glitches and system crashes are, let me give you one programming example to indicate a glitch. Have a look at this programming code. Well, this is a program that is being coded using the Java programming language. Just in case some of my learners are confused with this syntax of Java, then all that I can recommend you is to go through my course on the Java programming language. But then what I really want you to focus is on these set of lines wherein I am declaring an integer variable x and I am initializing it to say 10. And I am declaring one more integer variable y and I'm initializing it to 0, after which I'm trying to compute the result as x by y, after which I'm trying to print the result. Well, upon execution of this program, you may be expecting a certain output, but you know what? This program terminates abruptly. It leads to a runtime error. And why does all of this happen? Well, it happens because of this particular problem in the program. There is a division by zero glitch. Well, you were expecting a certain output, forgetting that you had actually given the denominator as 0, but then the program shall lead to a runtime error and shall abruptly terminate. Well, this type of a glitch is what we refer to as the behavioral glitch. Well, I know that it's a pretty simple example and that you would also be expecting examples for the other types of glitches, and let me tell you that moving forward in this course, definitely you shall be getting practical examples for all of the theoretical concepts that you are understanding and assimilating. But then, since we are still in the beginning part of the course, that all that I wanted to say is that this kind of a glitch is what we refer to as a behavioral glitch, because you are not expecting this behavior from your program, but then the program triggers an exception and does terminate abruptly. Well, that way, let me give you an example of a system crash. Let me again give you the example of a Java code. Well, in this program, what I'm trying to do is to allocate memory for an array, but then the size of the array happens to be the max value of the integer. This is what is being indicated in this line. Well, again, if all of this is confusing, I shall recommend you to watch my course on Java programming language. But then after allocating that much of memory, I then have a print command which is saying that the program shall continue as normal after allocating the memory. Well, say you have written the program like this in Java, and then in case you try to execute it, let me tell you, a system crash shall happen. In fact, it is a soft system crash that shall happen, and why it happens is basically due to this. Yes, integer.max value. Now, what is the maximum value of an integer in Java? Well, let me tell you that the maximum value of an integer in Java is 214 crores 74 lakhs 83,647. Now, what you are basically instructing your Java runtime environment in this line is that it should be allocating these many bytes of memory on the RAM. And not just should it be allocating these many bytes of memory on the RAM, they should all be placed continuously on the RAM. Well, again, all of this sounds to be pretty technical, but all that I wanted you to understand is that just in case your RAM does not have 214 crores 74 lakhs 83,647 bytes in it, then where from will your RAM allocate so much of memory? But then in this line, you are demanding your Java runtime environment to be allocating this much of space. And if really that much of memory space is not at all there on the RAM, then obviously the allocation cannot happen. Well, the control doesn't even go to the next line. Rather, in this line itself, the system crashes. Well, this is what we refer to as the soft crash, and it has basically occurred because you are attempting to allocate excessive memory in this program. So, I'm sure that now you understand that this program results in a behavioral glitch, whereas this program results in a soft crash. And you have also broadly understood as to what really is the difference between the glitch and a system crash. But then let me tabulate the differences for you in a structured manner. Well, you know that a glitch happens to be a transient or a temporary fault that is causing the unexpected behavior, but then a system crash happens to be a sudden and the complete failure of a program or a software system due to certain critical errors. That way, glitch often are short-lived and are intermittent, but then a system crash is more severe and disruptive. Well, glitches can lead to minor and localized issues in the software, but then system crashes shall result in a complete system failure and that the system comes to a grinding halt. Well, glitches that way can be resulting from various factors including hardware and software issues, but then the system crashes are basically caused by the critical errors such as memory exhaustion or due to the infinite loops present in the programming code. All said and done, we can overcome the glitches by just hitting the refresh button. In other words, with just minimal intervention, we can resolve the glitch. But then a system crash definitely cannot be resolved by just hitting the refresh button. Rather, it requires manual intervention and definitely involves a lot of debugging as well. So all said and done, I'm sure that in this session, you have indeed been able to understand as to what really glitches are and what really system crash means. Well, moving forward in this video series, you shall be understanding all such important terminologies and concepts related with software development so that you can be shaping yourself as a successful software developer. Hope this session was informative, and if you'll really have to keep on enhancing your knowledge horizon and then shape yourself into a formidable software developer which the industry cannot ignore without recruiting you, that you just have to continue watching this video series. Thanks for watching. Let's meet again in my next session.